All right, good morning, everyone. Today we're going to talk about angles of elevation and depression, which is just an application of trigonometry. So it's going to be using that SOHCAHTOA to find side lengths and things like that. But before we do that, just real quickly, I wanted to go through a quick review problem of a 45-45-90 and a 30-60-90 triangle, just to keep those fresh in our mind, because those are going to be on the quiz on Friday. So the first one here, we need to find both variables, x and y. Here's our picture, 45-90, which means this is 45. 7 is our hypotenuse. So we know the hypotenuse. For a 45-45-90 triangle, the magic number is the square root of 2. You're either going to multiply by the square root of 2 or divide by the square root of 2. Since we know the hypotenuse, we have to divide by the square root of 2. So it's 7 over square root of 2. At this point, the geometry work is done, and now you just need to go back to Algebra 1. And in Algebra 1, we learned that you cannot have a square root or a radical in the denominator. So to get rid of the square root of 2 in bottom, we're going to multiply top and bottom of this by whatever that number is. Since it's a 2 down there, we multiply the top and bottom by square root 2. 7 square root 2 is just 7 square root 2. We can't multiply them together because this one's not under a square root and this one is. Here, they're both under square root, so 2 times 2 is 4, square root of 4. And the square root of 4 is 2, so we can write it as 7 square root 2. Now, we knew the hypotenuse and we found a leg, so this is both x and y, because both legs in a 45-45-90 triangle are the same. So that is equal to x, and it is equal to y. Once you know one leg, you know both of them. All right. Now for our 30-60-90 triangle, here's 30, 90, add and subtract from 180, that has to be 60. Since that's our 60-degree angle, the side that we know here, that is our long leg. A is our hypotenuse, and B then has to be our short leg opposite of 30. If you don't know the short leg, our first goal is always to find that short leg. Since the one that we have is the long leg, we are going to, since we're going from something that's long to something shorter, we're going to have to divide. So we do 4 divided by the number we have divided by, and then to go from long leg to short leg, it is the square root of 3. Now we're done with geometry and we have to do some algebra. Now this ends up being very similar to this step here to finish it off. Since we have a square root in the bottom, we need to multiply top and bottom. We'll multiply top and bottom over here by the square root of 3 this time, because 3 is the number in our denominator. So 4 times the square root of 3 is 4 square root 3. Square root 3 times square root 3. 3 times 3 is 9. So square root of 9. And the square root of 9 is 3. No longer have a square root in the bottom, so we're good. That is our short leg, which they call B in this picture. So that is B. Now that we know the short leg, to find the hypotenuse is easy. We just double it. So we take this times 2. 4 times 2 is 8. And that is called A in that picture. Once you have your short leg, you multiply it by 2 to find the hypotenuse. All right, moving on to the new stuff. In this lesson, we're going to talk about angles of elevation and angles of depression. Elevation means an angle that's going up. An angle of depression just means an angle that's going down. And we will show you what those look like here shortly. So, here we have, at a circus, a person in the audience at ground level watches the high wire routine. A 5-foot 6-inch tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform? If the angle of elevation, that means an angle going upward from the audience member's line of sight to the top of the acrobat, is 27 degrees. So let's draw a little picture here. Here's the ground. Okay. It says that there is a platform that's 25 feet tall. So here, 25 feet. Here's our platform. And there's a person standing on top, and they are 5.5 feet, 5 feet 6 inches. So there's our acrobat on a 25-foot tall platform. It asks how far is the audience member from the base of the platform. So they want from the base of the platform to our audience member. They're asking us for this answer, or that measurement, I'll just call it X. It says if the angle of elevation from the audience member, who's down here at ground level, so there's the audience member right there. It says the angle from the audience member to the top of the acrobat, I missed. From the audience member to the top of the acrobat is, this angle right here is 27 degrees. So we have an angle, we have one side, we have to add those together for a total of 30.5. So really, all we have is 30.5 x and 27 degrees. So you read the problem, draw a right triangle, and then you use sine, cosine, or tangent to find what you need. This one here, we have our angle, 30.5 is opposite of it. X, what we're looking for, is adjacent. Remember, it's always what do you know, what are you looking for? In this case, what we know is opposite, what we're looking for is adjacent. Opposite and adjacent from SOHCAHTOA. TOA, tangent. Tangent of our angle is equal to opposite over adjacent, which we called X. So now in our calculators, make sure we're in degrees mode, DEG right there. So I do the tangent of 27, and I get that decimal. I have 0.509525 is equal to 30.5 over X. Again, we talked about you can put this over 1 and cross multiply if you want, but what you're actually going to do is X and that decimal will switch places. So we have to do 30.5 divided by that decimal. So 30.5 divided by that answer that we had, and I find out that X is 59.86. Does it say where to round? How far is the audience member from the base of the platform? I don't really see anywhere that it says to round, so I'll just put it at 2 decimal places. There we go. Read the problem, draw a picture, and then use SOHCAHTOA to solve it. So, at a diving competition, a 6-foot tall diver stands atop the 32-foot platform. So here's the pool, here's our platform. It says it's a 32-foot tall platform. You have a 6-foot tall diver. So the whole thing here is 38 feet from top to bottom. That's the whole thing. It says the front edge of the platform projects 5 feet beyond the edge of the pool. So from here to here, this is all pool. I'm gonna give it a wave to look like water. That's 5 feet. The pool itself is 50 feet in length. The camera is set up at the opposite end of the pool, even with the pool's edge. So right here is a camera. If the camera is angled so that its line of sight extends to the top of the diver's head, what is the camera's angle of elevation? We're looking for that angle, that theta, that x, whatever you want to call it. We're looking for an angle here. Since we're looking for an angle, that immediately should tell you you're going to use inverse trigonometry. So first, let's just redraw this a little bit more simplified. We have a right triangle. We have all of our different stuff right here. 50 and 5 of it has been cut off by the platform extending on over it. 38 here. So what we really have is 38 total feet up, 50 minus the 5 that it's overhanging, so 45 here. And we're looking for that angle right there. From this angle, we have opposite and adjacent. Opposite and adjacent from SOHCAHTOA. Tangent, TOA, is opposite over adjacent. So from SOHCAHTOA, we know we're doing tangent. Because we're looking for an angle, we do inverse tangent. And SOHCAHTOA says tangent is opposite over adjacent. So we do the inverse tangent of 38/45. So I'm going to do 38 divided by 45 gives me 0.8 for repeating. Now I have to do the inverse tangent, and you can type in that answer, or if your calculator has one for an answer, it's just reusing that decimal I had. So I get an angle of 40, it's to the nearest degree, so 40 degrees. It says to round to the nearest degree, so 40 degrees. Okay, here we go. It says Maria's at the top of a cliff. Here's a cliff. Here's a person at the top of it. Sees a seal in the water, so I guess there's water over here. All right. Sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression, this is the first time we've done depression, all that depression means is going downward rather than upward. So she's going to be looking down and sees a seal right here. It's a very cute seal. Well drawn. So it's an angle of depression. So that means going down. So that's this angle right here. If she had looked straight out, that would be horizontal, but she went down, or depressed, went down through an angle of 52 degrees. So this angle here is 52 degrees. We know that this side right here in our triangle, cliff is 40 feet. Here's a 52 degree angle, and they want us to find what is the horizontal distance from the seal to the cliff. So they want us to find that. So I'll call it X. All right, so 52 degrees is not an angle inside this triangle. We have 90 degrees, but we don't know either of these. We can use 52 to find one. This has to be a right angle, so you can just do 90 minus 52 and find out that this one here is 38. You can also do this line and this line are parallel, cut by a transversal, so alternate interior angles are congruent. So this one has to be 52 degrees. Either one works. It doesn't matter which one you choose. Either subtract from 90 and find this angle, or use alternate interior angles to find that this one's 52. Notice 38, 52 adds up to 50, adds up to 90. 90 plus 90, 180 for the whole triangle. So from here, you can pick either one of these angles. I don't care which one. Let's go with 38 for this one. So from 38, forget we didn't know this, from this 38, we have opposite over here, opposite, and we have adjacent over here. Again, opposite and adjacent. What do we know? What do we have? What do we know? What do we have? Opposite and adjacent. SOHCAHTOA, tangent is opposite over adjacent, so X, tangent of our angle, I forgot our angle, tangent of 38 is equal to opposite over adjacent. Tangent of 38 equals X over 40. So we do tangent 38, and we get 0.781286 is equal to X over 40, and to finish it out, we multiply both sides by 40. Notice that I leave a lot more decimals here, and then I round at the end. Make sure you do that, or better yet, just use this whole decimal here, use that answer and do times 40. So that's even using the whole decimal, not just this. But we find out x is 31. Does it say where to round? To the nearest foot, so just 31 feet. It says to round to the nearest foot, so I don't need any decimals. Okay, angle of elevation is an angle going up and is going to be an angle inside the triangle. Angles of elevation will always be in the triangle. Angles of depression are going down, and it's not going to be an angle inside the triangle. You either need to subtract from 90 or use alternate interior angles to find an angle that is in the triangle. All right, Luis is in a hot air balloon 30 feet above the ground. Here's the ground. Here's our hot air balloon. It is 30 feet. She sees the landing spot at an angle of depression of 34. So here it is. She sees a landing spot right here. This is a 34-degree angle. Okay, you can say that this is 34 degrees here because of all parallel lines cut by a transversal alternate interior, or you can subtract from 90 and find this one. Since we did the other one by subtracting, I'll do this one with alternate interior angles. And it says, what is the horizontal distance? So it's asking for this one right here, x. So we have 34 degrees in our triangle. Here's a right angle, 34 degrees, 30 feet, and we're looking for this. SOHCAHTOA. Opposite, adjacent, so again tangent. Tangent of 34 degrees is equal to opposite over adjacent. SOHCAHTOA, tangent uses opposite and adjacent. Tangent of our angle equals opposite over adjacent. So I do tangent of 34, and I get that decimal. So I have 0.674585 is equal to 30 over x. I can put it over 1 if we want, and cross multiply, or again multiply by x, divide by that decimal. So we have 30 divided by that decimal. 30 divided by that long decimal is 44.48. It asks for the nearest foot, so just 44 feet when you round it to the nearest foot. All right, a couple more examples here where we have, for these last two, we're going to have two different triangles going on in here. So how can we work these out? It says someone is on the top of deck of a cruise ship and observes two dolphins following each other directly away from the ship in a straight line. The position is 154 meters above sea level, and the angle of depression to the two dolphins are 35 degrees and 36 degrees. Find the distance between them. So we're looking for just this little tiny distance right here, J to K. That's all we care about. The easiest way to find that is to find JL, the side length in this triangle, and find KL, the side length in this triangle. And once you know this length and this length, just subtract them, and all you're left with is that little tiny piece. So we're just going to do this as two totally separate problems. One of them where we have KL, and this is a 36-degree angle of depression. We can subtract from 90 and find that this one is 54 degrees. And find x here. So that's K to L, that's this piece right here. And over on this side right here, I can go from J to L, JL, and that JL has the 35 degree, so 90 minus 35 is 55 degrees right there. For both of these triangles, that vertical side right there and there is the 154 meters. All right, now I just solve for x, and I'll call that one y, just so I have different things to call them, x and y. Here's my angle, 54 degrees. From that, x is opposite, 154 is adjacent, opposite and adjacent is tangent of 54 degrees is equal to opposite over adjacent. So I do tangent of 54 multiply by 154. So I find that x is 211.96. Okay, so 211.96 meters, and that is 2K. So that's to this closer, lighter colored dolphin. Over in this one here, I have the tangent of 55 is equal to opposite over adjacent. So to the further, darker colored dolphin, it's 219.93. Now, it only wants the distance between them, so we subtract them and round off to the nearest meter. So 219.93 minus 211.96, round off, so about 8 meters. Real close to 8 meters between them. So if you have two like this, just solve it as two separate triangles and then subtract or whatever you need to do to find what the question actually asks for. For the sake of time, I'm going to skip this problem here, and I'll just have you guys here. Here's your homework, 12 problems. Make sure you draw your picture for each of these, just like we did in all the examples we did. Draw a picture, label everything. Remember your SOHCAHTOA. Most of the time, a lot of the time, it is going to be tangent, opposite, and adjacent are the most common things. But every once in a while, you'll know the hypotenuse, so it might use sine or cosine. Please email me if you have any questions. Have a great day.